So the first question in understanding 4 is, what triangle congruence relationships must be true to prove triangles congruent? Y'all can put your computers back up and get to this page so you can look at stuff, so you can see it well. All right, so what triangle congruence relationships must be true to prove triangles congruent? Okay, so what's the answer to that question? Does anybody have a guess? What triangle relationships were we talking about on the back of the board? Yeah, it's talking about all those. It's talking about SSS. What does SSS stand for again? Side, side, side. Talking about SAS. What does SAS stand for? Side, angle, side. What's another one? There are 4 that we've talked about. We're going to talk about a few more today. AAS. AAS is what? Angle, angle, side. Okay. Now, what's the 4th one? That's a good guess, but that is actually not one. Angle, 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 and let's talk about that real quick. All right, if you have a triangle that has the same angles, like this one right here. Let's see. Okay, so we got that one. And then we've got a bigger one that's got the same angles. I'm going to draw it as best I can, more or less. Okay? But the angles are the same. Are these 2 triangles congruent? No. Okay? Now, somebody put that yesterday on something they turned in. But angle, angle, angle is not a congruence. Now, those 2 triangles would be similar, but not congruent. Okay? So angle, angle, angle is not one. Strike that one from your memory if you've thought one. Huh? Angle, side, angle. Okay. Okay, so those are the 4 congruence relationships. Now, there are a few more. They have to do with a certain kind of triangle. What kind of triangle do they have to do with? I'll give you a hint. There's 4 of them on the back of the board. 2 of the problems. Now, that's Osleys. That's a good guess. Right triangle. Okay. They're dealing with right triangles. Okay. What is true about a right triangle? Has a right angle. Right angle is what kind of angle? 90-degree angle. There we go. There you go. You learned something somewhere. That's good. Okay. So, 90-degree triangle, right? We know it's 90-degree triangle because we say that it's got a 90-degree angle, right? Now, our 4 from the previous page were side, 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 angle, side, and angle, side, angle. Okay? Right? Now, for right triangles, we only have to know 2 things. Okay? Now, there's 2 different kinds of sides on a right triangle. What are they called? What's the longest side called? Most of y'all probably know that one. What? Hypotenuse. That's right. Okay? Now, what are the other 2 sides called? What? Legs. Okay? So, hypotenuse and legs. Okay? There are, excuse me, there are at least 3 different ways you can prove a triangle. Okay? Now, look here. If you know on 2 right triangles that the hypotenuse and one leg are congruent, then those 2 triangles are congruent. Okay? So HL stands for what? Hypotenuse leg. Okay. Another one is LL. What do you think LL stands for? Leg, leg. Leg, 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 leg. You know, just leg, leg. Yeah, that's right. Okay. Okay. Excuse me. Now, a third one now. all right triangles have a 90-degree angle, right? One of our ones from the other side is angle, angle, side, right? Right? Yes? No? Yes? Okay, so this, but we know that it's got a 90-degree angle. So if we know that one other angle and the hypotenuse are congruent, then we know the triangles are congruent. So what do you think we label that as? We know the hypotenuse is congruent. What letter have we been using for that? H. There we go. And A. Hypotenuse angle. There you go. Good job. All right. You did. You done good. Okay. All right. Now, what about LA? Do you think that's going to work? We know one leg and another angle. Now, that one we would have angle, side, angle. Is that one of our congruence relationships from the other page? Angle, side, angle? Yeah. So, does LA work then? Yes. Why you say yes, 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 no? Okay. Yeah. Leg angle. So there's 4 more. Now, those are specific to, I'm going to say this again, those are specific to what kind of triangle? Right triangle. Okay. So how many congruence relationships do we have total? 4 plus is 8. So we have a total of 8. These 4 and the other 4. Okay. All right. Let's go back to our page and look at it again. Okay. All right. Second question in understanding 4 is, how can coordinate geometry be used to prove triangles congruent? What is coordinate geometry? Let's break that down a little bit. Okay, what is the coordinate? Does anybody know? On a plane. Okay, so we're talking about, no, not like an airplane, like a flat plane. You know, kind of like a plateau, but not. You know, oh, that's the wrong thing. Okay. So we're talking about XY axes, right? Okay. Coordinate plane geometry. Now, how would we name a triangle in coordinate plane geometry? How do you create a triangle in GeoGebra? You do what? You go doot 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 doot. So you put doot doot doot. Okay. So you put point, 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 right? Yeah, you got to connect it, end it there. But so you label a triangle with 3 points, right? So that's how you do it by hand too. So let's look at a triangle. So label our point, and we're going to call this one 0, 0, just for grins. Okay. Then we label another point out here. We'll call this 5, 2, just for grins. And then we'll label another point up here and label it 2, 5, just for grins. Okay. So now we have a triangle, don't we? Yes. You got to make your lines, and then you have a triangle? Yeah. Okay. Is it what? Yeah, it's great for you to write notes. It's a good plan. That kind of messed up, didn't it? So forget the shape recognition and just put it on there. Okay, so there's our triangle. All right. Excuse me. So there's a triangle. Now, you need to know what angles, your angles measured on coordinate geometry, and you need to know the lengths of the sides, okay? So, how are you going to find out those two things? Huh? If you want to know the length of the sides, If you, I've been recording myself the whole time. I did. Okay, probably got you saying that. Okay, now, what was I talking about before I was interrupted? Oh, distance. Okay, now, if you don't have a ruler, how do you find distance between 2 points? It's on the board. Distance formula. Okay, I'll write that up here so we have it. Okay, so distance formula. D equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Okay, distance formula. How do you use the distance formula? Yeah, you just plug it in. Okay, so we find the distance between here and here, we just plug it in there. Distance between here and here, we just plug those in there, right? Now, ordered pairs go yx or xy? Xy. Okay, that's something you have to know. If you don't know that, memorize it somewhere, somehow. XY. Just remember that X comes before Y in the alphabet, and then there you go. You got it. Okay. All right. So you can use the distance formula to find the length. Now, right now in your math career, you can't find the angles without a protractor. Okay. So if you're using coordinate geometry, which congruence relationship do you have to use? If you can't find the angles, which one do you have to use? Side, side, side. Okay. So if you don't have a protractor, you have to use that one right now. You can find the angles later, but we don't know how to do that yet. Okay. Now, how could you find out if it was, now this you could do, and let's talk about this. You could find out if it was a 90-degree triangle. How would you know that you have a 90-degree angle? Well, you can see it, but you can't go based just on that. Yeah, they would. They sure would. And I definitely would, because I'm mean like that. Okay? Right? Now, 90-degree angle, two lines that meet at a 90-degree angle are called what? Perpendicular. Okay? All right? Well, that won't work, will it? Okay. Perpendicular lines. Draw some that are more or less perpendicular. It's one, and another one that looks at least close. Okay? And then we can cover over our inadequacies by saying it is. Okay? All right. Now, so we got two perpendicular lines. Now, we've talked about this before, the slopes of perpendicular lines. How do we tell from the slopes that they're perpendicular? Slope, how do you find the slope between 2 points? Over. So if we had the point 1, 2, and then another point 3, 4, you just plug it into that formula. M, because M stands for slope in our world. B, yeah, y2, 4, minus y1, 2, over x2, 3, minus x1. Okay. Then you find your slope. Now, the slopes of perpendicular lines are opposite, which means one of them is positive and one of them is negative. Reciprocals, what does that mean? What does reciprocal mean? Anybody remember? No, a negative sign is just opposite. Reciprocal is different. Yeah, it's a fraction flipped. Okay, so opposite, and then we've got our fraction, and we flip it. Okay? Perpendicular lines have opposite reciprocal slopes. So if you have two lines on your triangle that are perpendicular, then what kind of angle does it have? 90. So you can use one of these four. Right? Now, if you forget that, use one of those. Okay? All right, let's go back to our page. How y'all doing? Y'all following along, more or less? Specific postulates and theorems that it's talking about. It's talking about SAS, SSS, ASA, AAS. Number three is fine. Y'all got that, at least for the most part. Okay. Well, postulates and theorems allow triangles to be proven congruent. Same thing. Okay. How do we use them? We look at the three sides and see if they're the same, and then if they are, then they're congruent triangles. Now, excuse me. Last thing real quickly. I think y'all pretty much have this, but I don't know if you have what it means. What does this, now y'all know what this stands for, most of you anyway. What does that stand for? Congruent? I mean corresponding. I always do that too. I always have to mentally correct. Corresponding. Now, what does corresponding mean? Kind of. Yeah, I know what you mean. Like, if we have the triangle up here, we have this triangle right here. Then we have, hopefully, the same triangle right there. At least close. Okay. And then we label the triangles A, B, C, and then D, E, F. And then we say, now, what do you have to know in order to use CPCTC? No. That's what it tells us. What do you have to know in order to use it? It's the opposite of what you just said. Sort of. No, not the theorems. He said the parts are congruent. He said that you have to know that the parts are congruent, but that's not what you have to know. This is where we're oh my goodness. I still had shape recognition on. Doesn't that look awful? How do I turn the stupid thing off? There we go. A, B, C, D, E, F. That's an F. Okay. All right. Sorry, y'all. Okay. Now, okay. So you said the parts, you have to know the parts are congruent, which is not true. That's the one. You have to know that triangle A, B, C is congruent to triangle D, E, F. Okay? So, in order to use CPCTC, you have to know that the triangles are, you have to already know that the triangles are congruent. That has to be given. Right? Okay? So, in order to use side, 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 what do you have to know? Well, you have to know what it means. You have to know that SSS means side, side, side. But in order to use it, what do you have to know? What's your goal when you're using side, side, side? In side, 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 you're trying to say that these two triangles are congruent. With CPCTC, you already know they're congruent, and you're trying to say that AB is congruent to DE. Okay, so this is for proving parts. The others are for proving triangles. Okay. Just think about that there are more parts than there are triangles, so there's more letters. This one's for proving parts. The other one's for proving triangles. Make sense? Clear as mud?